so that takes care of half of the burden. I'll talk about energy efficiency and general what's happening and what's the confusion and what is required to have some bigger momentum into the energy efficiency for the buildings. So before we go into what's happening and what are the techniques, let us have a quick overview of how the energy flows into building. So basically there are two major components. One is the energy flow through the shell, that is the wall, roof, floor, windows, and the other is the heat that is generated within the building. So we have two sources of heat. I'm by default assuming that we are talking about buildings in and around this area and heating is not required, cooling is the predominant requirement. If heating is also required, then there will be some changes. So here we are assuming that it's going to be a cooling required building, and therefore we have heat that is coming through the roof, which is not desirable, heat coming through the walls, heat coming through the glass, through conduction, and that is just like a wall. Not to worry about the light coming in through the glass, just the heat that comes through the glass as if it was a wall. And then we are bringing in fresh air, so that also brings in heat. All these, they are part of external heat gains. They are coming from outside to inside. Now interestingly, the solar heat gain, which is the solar radiation that comes in directly from the glass into the building, constitutes internal heat gain, because this heat comes and is absorbed by the surfaces and then re-emitted. So the glass contributes in two ways to the heat that comes into a building. One, because of the difference in temperature between outside and inside, and therefore the heat flows in. Another is radiation which comes in directly from the glass and comes into the building. So internal heat gain, we are contributing to the heat. By the way, how much is each person contributing? Any idea? It's about 100 watts. Each of us is like a 100-watt heater or a 100-watt lamp. So we are contributing 100 watts each, and that's huge actually. There are 100 people sitting here. It's about 10 heaters we kept here. And then we have, and there's no substitute unfortunately. We can't say that substitute incandescent lamp with CFLs. So we have a lot of heat that is generated by the lights. We have heat generated by all these projectors, computers, equipment. So that is the internal heat gain, and we have to remove it. So if you see what is the contribution of these different gains. The first graph is energy consumption. It tells you where is our electricity going. So these numbers change. These numbers can change dramatically from inefficient building to efficient building, low-rise building to high-rise building, office building to commercial building to mall. This is just an indicative number. So you see that, say, 1/3 of the electricity is actually going into air conditioning.